So we are given two curves, y is equal to 1 upon x, so that is xy equal to 1, and the second curve is y equal to ln x. So let's draw the diagrams. Y is equal to 1 by x will be a rectangular hyperbola like this, and we will have to draw the graph only for the positive values of x because ln x, so x cannot be negative, and the graph for y equal to ln x will be like this, and it will intersect the x-axis at the point 1, 0. Let D1 denote the region surrounded by C1, C2 and the line x equal to 1. Okay, so it's just this line x equal to 1. Let's draw it. Yeah, this is that line x equal to 1, and we don't know the point of intersection of C1 and C2. We don't have a method of finding it in this case, so let's just assume it to be some alpha. So it is some point alpha, and D2 denotes the region surrounded by, okay, first we didn't find out D1, so D1 is the line and C1 and C2, so D2 has to be this region, the line C1 and C2, and D2 denotes the region surrounded by C1, C2 and the line x equal to A. So A has to be greater than alpha definitely. So let's draw this line x equal to some A. So this is x equal to A, and D2 will be this region. Alright. Now they have said if D1 equals to D2, we have to find the value of A. So let's write D1 and D2. So D1 will be equal to, it is x from 1 to alpha. X goes from 1 to alpha. So the limits are from 1 to alpha, and the graph is, so the upper graph minus the lower graph. The upper graph is y equal to 1 upon x. So this is 1 upon x minus the lower graph, so that is ln x dx, and d2 equals to limits from alpha to a. Now in this case the upper graph is ln x and the lower graph is 1 upon x, so ln x minus 1 upon x dx. And another thing, at alpha will satisfy both the equations. So for alpha, 1 upon alpha is equal to ln alpha. So we might need this somewhere. So let's just make a note of that. So now they have said that D1 equals to D2. So we will make them equal. In the first case, integral of 1 upon x is ln x minus integral of ln x is x ln x minus x, and the limits go from 1 to alpha, and this is equal to d2. So that will be ln x, the limits, the integral of that are x ln x minus x, and minus 1 upon x, the integral of that is ln x, so that is minus ln x, and its limits are from alpha to a. So let's start substituting the values. So here we will have ln alpha minus alpha ln alpha minus alpha, and then for 1 ln x and ln x will become 0, so we are left with just minus 1, and this is equal to, now writing the values of a, so this is a ln a minus ln a minus, substituting alpha, it will be alpha ln alpha minus alpha minus ln alpha. Okay. So now let's see if anything is cancelling. Alpha ln alpha will cancel from here and here, and this will cancel out with this, and plus ln alpha will cancel out with plus ln alpha. So finally, after cancelling out everything, we are left with only minus 1 is equal to a ln a minus ln a. Okay, let's erase some part. So taking a to the other side, we have a minus 1 equals to ln a minus 1, a minus 1. So we know that a cannot be equal to 1, so we'll just cancel this out. So ln a is equal to 1, so a is equal to e, and this will be our answer.